Hey guys, so today is September 14th, 2020, and let's talk about what we are going to do today. Hold on just one second. Okay, now you should be able to see me. So today you need to complete your geology notes, do slides 9 through 13. You're going to do doodle notes on a PowerPoint based off of tectonic plates. After that, you're going to complete your notes on the continental margins and the deep sea floor. So let's go ahead and get started. I'm going to bring up the geology notes first, and we're going to start with those. So we're going to do the geology notes, slides 9 through 13. All right, so this is where we ended on Friday, and we talked about if the continents keep spreading, why doesn't the globe get bigger? And we talked about how one continent slides underneath the other one, but that's not always the case. So let's talk about exceptions to that rule. The first thing that happens is we're going to talk about when an oceanic plate meets a continental plate. When that happens, the oceanic plate always slides underneath the continental plate. It causes volcanoes and coastal mountain ranges. The best example we have of this is the Andes Mountain. We have this continental plate right here that has South America on it. This is actually a picture from Google Maps. You can see the continental plate right here. You can see this oceanic plate over here off to the side. The oceanic plate is going to slide underneath the continental plate. As that magma in the core of the earth starts to melt down the earth, it's going to rise. Remember, heat rises, the convection current model. That heat's going to rise up. We're going to create a volcanic mountain range. So we have these Andes Mountains right here along the side of the entire continent of South America. The next type of border is oceanic versus oceanic. So when oceanic plate hits an oceanic plate, one oceanic plate slides against the other. We don't know why one is favored over the other one yet. It just is at this point. I wish I had something better to tell you. I know that's not a good reason. It causes volcanoes to rise up just like when an oceanic plate slips behind a volcanic plate. And it creates an arc of islands. They're volcanic islands, and they come about because of the magma rising to the surface. Again, heat rises. The same way those mountains are formed on a continental plate, they're formed on an oceanic plate in the ocean. The way you can tell that it's an oceanic volcanic arch is because it's going to make a circle, or half of a circle. The earth isn't flat, y'all. The earth is rounded. So when one plate slides against another one or underneath another one, it creates this rounded arch of islands. This one right here is in Alaska. It's called the Aleutian Islands. It comes off of the border of Alaska. This one down here is the most popular island archipelago that we have usually when we talk about this. This is the Mariana Islands. This trench right here in front of the Mariana Islands, where one oceanic plate is sliding underneath this oceanic plate right here, is the largest trench in the world. It's also the deepest place in the world. Last but not least, we have a continental plate hitting a continental plate. So when both plates hit each other, both plates float and neither one of them is subducted, meaning neither one slides beneath. They hit each other, and they hit each other with so much force and hit each other dead on that they begin to rise up, and they form a mountain range. This is my cat. Welcome my cat, April May. Come on, April May. So they push against each other with such force they weld together, and it causes a rise and a buckle. The most notable one that we have is the Himalayan mountain range. We've got the Eurasian plate up here and the Indian plate down here. As the Eurasian plate hits the Indian plate, these mountain ranges come up and form. If you look at it from the Google Earth image, it's very clear the two different types of land we have. We have a dry, arid, brown land over here. Over here, this continental plate, the Indian plate, is made up of a much greener, much healthier type of soil and land. But there's an exception to all of those things. There's always an exception to the rule. It's science. So the exception is going to be that sometimes plates slide past each other. Instead of running into each other, they're going to slide past each other. Plates that make that sliding motion don't collide, and we call that a shear boundary. The zone they move past each other at is called a fault line. And there's lots of friction that prevents them from moving smoothly. If you've ever looked at rocks outside, usually, unless they've been eroded for millions and millions of years, they're going to be jagged and have jagged edges on them. So when they go to slide, they lock up against each other. And they continue to push on each other with force until finally it breaks and slips through. And it causes a massive earthquake. If you've ever tried to force something together, you'll know that like you can force and push and forever and ever, and it's hard to push it in. And then all of a sudden, like it gives and everybody falls down, or you fall over because it finally gives. The same thing is going on in the Earth's crust. The most notable one in America is this San Andreas Fault. It runs from Southern California up to Northern California. This is a picture of it in Southern California. You can actually see the fault line where it moved. Some of the most notable earthquakes in the United States have occurred along the San Andreas Fault line up here in the San Francisco Point Reyes area. It was either the 96 or the 98 earthquake. Point Reyes, California. It happened in San Francisco Point Reyes. It was around an 8 on the Richter scale, meaning it was an extremely bad earthquake. If they would have just listened to the sea lions, all of the sea lions and marine life actually evacuated San Francisco about 2 days before the earthquake hit. No one knew where they were going or what they were doing. Turns out there was going to be a massive earthquake. But this is Point Reyes. You can see that in that San Andreas fault slip of that earthquake, that it moved 16 feet. So before the earthquake hit, this was somebody's fence line on their property line. When that fault line finally slipped, their fence literally moved 16 feet. If this fault line continues to move, Point Reyes in your lifetime will no longer be attached to the state of California, and it will become a free-floating island. Obviously, no one lives on not San Andreas. Nobody lives on Point Reyes anymore. It's owned by the national government now. So once you get to this point in your notes, it's time to take a break from taking notes for a second, and you are going to pull up the worksheet that looks a little something like this. It says Plate Tectonics. If you go into today's folder, you'll see that I again, nope, hold on. There they are. I gave you 2 choices again. So you can do the assignment as a PDF file, or you can do it as an editable PowerPoint. Remember, though, if you save it to your OneDrive, you cannot just send me a OneDrive link. You have to physically upload it. I can't see what's in your OneDrive, just like you can't see what's in my private OneDrive. So you can't just send me a link. You've got to physically upload the assignment to me. What you're going to do for this assignment is you are going to pull up this PowerPoint that says Plate Tectonics Doodle Notes. And you're going to start at the very first slide, and you're going to go through these notes. And as you go through the notes, it gives you instructions right here. So you're going to need a regular pencil or pen for writing key ideas neatly. Colored pencils work best for adding color. Focus on the main ideas. And listen for doodle tips that will help make your notes easier to remember and study. Doodle notes take some work, but you'll notice they really help you learn. So you're going to notice as you click on each slide, you're going to have a picture on the top that matches a picture somewhere on your worksheet. So this one says Plate Tectonics. What is it? And it's the interaction of the Earth's rigid lithospheric plates as they slide slowly over the asthenosphere or the mantle. So it gives you tips on the bottom. Doodle tip, write small and neat to get this to fit in the space provided. Bold important words by tracing over the letters more than once. So if I wanted to put this on this worksheet over here, I'm going to go to File, I'm going to insert a text box, I'm going to put it right up here at the top, and I'm going to type it what it is. It's an interaction of the Earth's rigid lithospheric plates as they slide slowly over the mantle. And then it says to bold the important words and underline them. I'm just going to keep following instructions just like it says. Up. And I'm going to keep going through this PowerPoint. So evidence, fossils, locations of earthquakes, land warping, ocean floor spreading, continent shapes like puzzle pieces. There's all of the evidence in one place. We've got the convection. It talks about the 3 plate boundaries. So this is just for you to review. When you get to the very last page, it says go over your notes with color, checking key ideas together. Use only a few colors. Embellish areas around your text. While you color, think about the big ideas and how they relate. Color with intention. So it says your doodle notes don't have to look exactly like the example, but they should have keywords and information. Just because you're on a computer does not mean that you cannot highlight things and make them pretty. I can make my box bright blue and put white text on it. That way I can see it better. You can highlight your boxes. You can highlight different areas. Chunk it out, make it understandable, and make it what works for you. All right, and once you finish that, the last thing you have to do today is finish the PowerPoint notes. So the sea floor is similar most everywhere in the world because it's formed by the same processes. There are 2 main areas, the continental margin and the deep sea floor. These notes might be confusing. Let me kind of give you a heads up when you're doing these notes. So like it has a capital A right here. It's going to go where the capital A is on your notes. Where it has the little a right here is going to go where the little a is on your notes. And then where it has 1, 2, and 3 in Roman numerals, you're going to put in 1, 2, and 3. And so on and so forth down the page. So the continental margin are a boundary between the continental crust and the oceanic crust. They consist of 3 parts: a shallow, gently sloping continental shelf, a steep continental slope, and another gently sloping region known as the continental rise. The continental shelf is the shallowest of the continental margin areas. Its slope is gentle to see with the naked eye. It accounts for about 8% of the surface area of the ocean. It's the richest part of the ocean. It's got the most biologically diverse animals, and it's got some of the most animals that we have in the entire ocean. During low sea levels, this continental shelf can be exposed. So if you're at the beach swimming, the area you're swimming on is the continental shelf. It's what you walk on. It's what you swim on. It's where the water leaves when it's low tide. And it ends at this shelf break, which is right here. And it's where it drastically drops off and goes through this slope. And it gets abruptly deeper. The continental slope is the closest thing to being an exact edge of the continent that we have. If we're measuring to the edge of a continent, we measure to the edge of the continental slope. Yes, that point is underwater. We're still measuring to the point where there's an extreme drop-off. It begins at the shelf break and it descends downward to the deep sea ocean floor. And Finding Nemo, if you ever hear them saying that they're going to the drop-off, this is where they're going in Finding Nemo. They're going to the edge of the continental slope. And when he swims out past the drop-off, he's swimming out past over this continental slope. So it is very dangerous for Nemo to be traveling out into that continental slope area. The continental rise is as the sediment moves down the slope and the slope moves down the shelf, and the slope to rise, and it deposits in a fan up here or down here, kind of like a river delta. As you get to the bottom of the river, all of that sediment runs out of the river and forms a delta. All this sediment is coming back with the backwash from the waves. It's going over the continental shelf, down the slope, and it's coming down and making fans. And all these fans merge to make the continental rise. And the continental rise is a slow slope to the very bottom of the ocean. And I'm pretty sure that is where I said to stop today. It is. All right, so that's it for today. If you have any questions, feel free to email me. I hope these little daily videos help you figure out what you need to be doing for Miss Neal's class.